course not. So if you have 12 going into 2746. 12 goes into what? How many times? Twice. So do I put the 2 above the 2 or above the 7?
0 above the 2, just for a place.
You get one question right, you think you own the world, right? You subtract, you get 3. Now what do? Drop down the 4. Get a 2 again, multiply out 24, subtract, you get a 10, drop the 6. 8 is 96, right? Yeah. 8 is 96. Yeah, good luck, right? No, it's called being resourceful. And you're left with 10, right? Now, normally you guys would then go to a decimal and drop it like that. But remember when you first learned long division, you guys would write that as the remainder? You know? Oh, that's a sad day. I'm sorry. You'll figure this out real quick. No problem. You guys would write remainder of 10.
Yeah, and I realized it was false.
But then you realize it was false because it's a fractional amount. The remainder, so if this is 228, the remainder was a part of what you're dividing by, 10/12. It just so happens that it simplifies to 5/6. But in essence, this remainder value always went over what you were dividing by. Well, these rules as far as how you do long division doesn't change when you're dealing with polynomials. The reason why I wanted to show you guys this long division by polynomials is because eventually we're going to have what are called slant asymptotes. Exciting.
Sounds
I can understand what you just said.
Slant asymptotes is something we'll use later on with conics, and then you guys will see again next year. I just wanted to show you guys how this works and how this does. It's really not that difficult of a process. After that, we're going to get into how you use remainders and how you can use factoring via synthetic division. You guys did synthetic division last week. Remember the upside down L looking thing? You guys flew right through it. They're relatively quick and painless, and we're going to show you how you can use this to factor and make your lives a lot easier. Okay? So let me show you an example of dividing by with polynomials via long division. When you're dividing these things out, just like we did with synthetic division, we always want to make sure that we have everything written in that descending order with nothing missing, none of our degrees missing. In this case here, we have a 3rd degree polynomial, and I have 4 terms. Am I missing any values? No. If I was missing a value, what would I have to put in?
0.
Good. Like a 0, whatever the exponent is. Yeah. So we start out by just writing what we're dividing. We're dividing that by 2x plus 3. Now, this is a little bit different than regular old boring long division. When we did regular old boring long division, we were trying to see how many times does 12 go into 27. Now I'm going to ask it a little bit differently. How do I change a 2x into a 2x cubed? In other words, what do I multiply 2x by to turn it into 2x cubed? Just x squared. Okay? So if I want to multiply it by x squared, where do you think I have to put this? Above the x cubed, the x squared, the x, or the constant? X squared. You always put it above the value of the degree. Okay? Now, just like you did before with long division, I would take 2 times 12, and I got 24. Now I'm going to take this x squared and multiply it times 2x plus 3. X squared times 2x is 2x cubed. X squared times 3 is positive 3x squared. What do you think I do now? Subtract. What I'm doing here, each time I go through this, I'm eliminating one of the next highest degree as I go through this. I have 0x squared now. Negative 7 minus 3 is what? Very good. drop down to negative 17 x. Just like we would do in regular long division. Now I want to multiply it, what do I multiply 2x by to turn it into a negative 10x squared? Very good. Multiply it by negative 5x. Take that negative 5x, distribute it over to here again. Negative 10x squared minus 15x. What do you think you do again?
Get rid of negative 10.
Subtract them.
Oh, yeah.
Negative 10 minus negative 10 is 0. Negative 17 minus negative 15 is negative 2x. And then drop down to negative 3. Watch your stories. And then lastly, I want to turn a 2x into a negative 2x. What do you multiply by? Negative 1.
Cancels everything.
And then you multiply that in over here again. You have negative 2x minus 3. When you subtract it out, you have no remainder.
Oh, that's naughty.
So when you divide 2x cubed minus 7x squared minus 17x minus 3, if I divide that by 2x plus 3, I get x squared minus 5x minus 1.
That's kind of cool.
No, because I'm multiplying. I want to turn it into the exact. I want to turn it into the exact same thing because I'm subtracting that.
Yeah, so you still correct it this way.
No, because if I multiply it by the negative, then I'd be adding. It's different. You always want to multiply. You want to turn each one of those values into the same thing. Okay? Really isn't that scary, is it? Now, it's weird, isn't it? For those of us that have never. Let's do another one.
Oh my.
Now, bless you. I have 2x to the 4th plus 3x cubed plus 5x minus 1. Right away, do you notice that I'm missing something? I'm missing an what? It says divide.
I know, but there's no stuff. But it says divide.
Just stop.
Is there a degree that I'm missing?
Yeah.
X squared. What do you have to put in there? Good. So you start out by writing out what's going to go underneath the little divisor symbol. I don't even remember what that's called. 2x to the 4th plus 3x cubed plus 0x squared plus 5x minus 1. Is it the quotient symbol? Quotient is the answer. The radical is the square root.
Can't use the vertical.
All right. Once again, I want to turn x squared into 2x to the 4th. What do you multiply x squared by to turn it into 2x to the 4th? Okay, perfect. 2x squared. Where am I going to place that? Over the x squared. Take this now and multiply it to all three of these. And then subtract them. 2x to the 4th goes away. 3 minus negative 4, 7 x cubed. 0 minus 4 is negative 4. Drop down to 5. And once again, I want to change my x squared into 7x cubed. What do you multiply by? 7x, very good. Send it over. Remember, whatever you multiply by the 7x, you have to multiply it to all three of those terms. Rewrite them below, and then you would subtract again. 0, 10x squared, minus 9x, and then drop down to negative 1.
-1. We're here to have fun.
No.
Yeah, thank you. And then lastly, what do I take the x squared by to multiply it to equal 10x squared? 10. Distribute through again. -9 minus -20.
Positive 11.
Very good. -1 minus 20. Now, I have, that's now a remainder. Do you agree? That's a remainder. There's nothing left for me to drop down there. So now, since that's the remainder, I take that as the fractional amount. So my final answer, I'm just going to write over here, I have a little bit of space then. My final answer would be 2x squared plus 7x plus 10. Is that 11x positive or is 11x negative? Positive, so I write plus 11x minus 21 over x squared minus 2x plus 2. That's that remainder. Very similar when we divided out, the 12 went into 27/46. We wound up with 228 and 10/12.
Yeah.
Same exact idea. All right, it's the same exact idea. That is what we call polynomial long division. It's not scary. It's not too tricky. Where do you think you're gonna screw up?
All the way down.
Signs. Yeah, you're gonna screw up your minus all those negatives. That's usually what you're gonna mess up. Okay? So let's do something which is a little bit different. Hold on. You all right?
Oh, you got it.
You all right?
If you like to switch it, I bet you otherwise.
It is the synthetic division is a lot easier, but sometimes with synthetic division you're not going to be dividing out by trinomials. Synthetic division you're dividing out by zeros, or you're dividing out by just binomials. Okay. So let me show you this. Once again, let's revisit synthetic division, and I have one big important note here. When you are working with synthetic division, you always want to divide by whatever the term's zero is. For example, if I'm saying that my term is x minus 2, what's the zero of that? 2. The zero would be 2. If my term is x plus 3, what's the zero? Negative. Whenever you're doing synthetic division like this, you always want to divide by whatever the zero is. So now, when I go and set up synthetic division, remember, you go in descending order, you take all your coefficients, put placeholders in for anything that's missing. 1, 2, -6, -9. And it asks me to divide it by x minus 2. Remember, if the term is x minus 2, when I divide it, I have to divide it by 0. So the 0 of x minus 2 is 2. I'm doing that, there's 2 parts. There's 2 problems. Let me show you both of them. I'm just restating it. What was your first step in synthetic long division? Or synthetic division, excuse me. Drop the 1. Yeah, bring down the first term. Now we take 2 times 1. We write it here. Now we add going this way. What's 2 plus 2? 2 times 4? Negative. So, now here's the trick. When they're asking you to synthetically divide out, they're asking you to find what's the answer. Well, up to this point when we did synthetic division, all you guys knew is that that last answer would have been, if you substituted in 2 for the problem, you'd get -5. But in essence, when you're dividing out like this, what happens is we start with a cube term. What's 1 less than a cube? Square term. So this is your x squared, this is your x, this is your constant, and this is your remainder. So if I divide x cubed plus 2x squared minus 6x minus 9, if I divide that by x minus 2, my answer would be x squared plus 4x minus 2 minus 5 over x minus 2. Because that negative 5 is the remainder. No, not necessarily. If there's a remainder, that's what that would look like. If there wasn't a remainder, what would be in that last column, that last spot? It would be a 0.
Wait, how did you get the E?
Hold on, good, hold on.
What is it?
Why is the 2 negative?
Couldn't you
Oh.
multiply after x minus
I just, what was it?
2? Divide by x minus
No. There's no equals. That's your remainder.
That's fine.
Yes, Shay?
So for like up at the top, where you got x minus 2 and you used a 2, do you just flip the signs?
You're always divided by the 0. Always, always, always. Gun, you had a question, sorry.
What do you mean divide by 3?
The 0, if this is your term, if you're factoring, you get a term of x minus 2. What makes that 0? 2, if x is 2. That's what I mean by divide
So
by
if
0.
you're dividing by x plus 3, you divide it by, I don't know, x 2 is going to be 2.
Correct. I thought your name was that though.
Um,
Let's do the same thing with the other one, with the x plus 3. If I'm going to divide the same thing by x plus 3, what's my 0? Negative 3. So I set that up with the negative 3 out front. Take your coefficients, which were 1, 2, negative 6, and negative 9. Again, the first thing you do is drop the first term. Negative 3 times 1 is negative 3. 2 and negative 3 is negative 1. Negative 3 times negative 1 is 3. Negative 6 and 3 is negative 3. Negative 3 and negative 3 is 9. Negative 9 and 9 is 0. In this case, was there a remainder?
No.
No, but when I divide that out, what is my answer?
Square minus x minus 3.
Minus x minus 5.
And that's my answer. Remember, whenever you're synthetically divide, whenever you're done, that next row is always 1 degree less than what you started with. Okay? Because the other one you have to know how to do, like I said, to find slant asymptotes, which we will eventually. I'm just introducing it to you. It's not as very important as far as this chapter is, as this is. Yes?
Earlier, your problem was that x cubed.
Yes.
So it's like,
Yeah, x cubed plus 2x squared minus 6x minus 9. All right? As I was saying, whenever you're using synthetic division, there are many things that you can do. In this case here, I'm setting it up just to divide out. I'm also going to be able to see if I can divide and factor. How?
no, like legs.
Are they really ash?
I can factor a polynomial given a 0. I want you to look at what they're writing here. This says f of negative 3 is 0. So if f of negative 3 is the 0, when I'm synthetically dividing, am I using negative 3 or am I using positive 3? If this is the 0, am I using negative 3 or positive? I'm using negative 3. What'll happen here is it'll state f of negative 3 equals 0. It'll say negative 3 is the 0, or it'll say divide by x plus 3. It says divide by x plus 3, you have to make the 0. Here they're telling you this is the 0, so you don't change the sign. You have to just read it carefully. So what this allows you to do from factoring is that it's going to allow you to start with a nasty polynomial. They give you a 0, and it becomes an easier one to work with. Again, knowing that you have the 0 of negative 3, if my 0 is negative 3, What's the term? If the 0 is -3, what's the term from the parentheses? X plus 3. Okay? We're working backwards. Instead of giving the term, find the 0. Here's the 0, find the term. So all I'm asking is the reverse of what you're accustomed to seeing. Again, take your coefficients, 2, 11, 18, and 9. Drop it down. Shh, gentlemen. And I get that. So when I divide out by -3, knowing that -3 is a 0, I get 2x squared plus 5x plus 3. And it's asking you to factor this. Well, that means right now you have 2x squared, 5x, and a 3. You can factor that. What's 2 times 3? 6. What times what is 6? You add together to get 5. 3 and 2. So what they're doing here is that they're starting with this nasty looking polynomial, giving you one of the zeros of it, and it's making it to an easier polynomial to work with. In this case, instead of going from the 4th degree, it's going right to a trinomial. So then you take your 2x squared plus 2x plus 3x plus 3, and how do you factor something with 4 terms? Group them. GCF. So way back up, oh, we'll write this first, x plus 1, 2x plus 3. And way at the very beginning of the problem, it gave you a 0 at f of, it was -3. If the 0 was -3, you guys told me my term was x plus 3, which means my final part is that.
Hopefully this will all fall into place.
What happens again, if they're giving you the 0, write down right away what the term is. Remember, it's just going to be the opposite sign. Use synthetic division. It takes it down a degree, and then it comes into something that's a little bit cleaner to factor. Yeah, Shay?
So if you would have had a remainder, then you just leave it as it is, and you still factor it out.
If you have a remainder? If they're giving you a 0 to start with, it probably means you're not going to have a remainder. It might have meant you did something wrong.
Like on the problem before though, would you still factor that?
No, you can't factor anything further.
Okay, that was just.
Guys, come on. It's just here's the coefficients. Okay. All right. So you're going to be given the polynomial and a 0, and it's going to ask you to factor it all the way out. Okay. They might say, here's the polynomial, here's the 0, find the other zeros. If that's the case, the only thing that changes is that there would be an equals 0 here. That would be the only thing that's different. Again, x cubed minus 2x squared minus 9x plus 18. X equals 2 is a 0. We're going to find all the other zeros. Basically, we're going to do the exact same thing, but at the very end, I set it equal to 0. So I know that they're telling me that x equals 2 is the 0. If x equals 2 is the 0, what's the term? X minus 2, very good. So I'm just going to put that here right away, so I don't forget it. I'm using synthetic division all the way through. I know my 0 is 2. I pluck out my coefficients. 1, -2, -9, and 18. As I start this, I drop that first value. 2 times 1 is 2. -2 and 2 is 0. 2 times 0 is 0. -9 is 0 is -9. 2 times -9 is -18. -18 is 18 is 0. What's the new polynomial you're left with. X squared minus 9. And up here, I have the x minus 2 already. And I'm finding all of the zeros. Could you tell me my zeros for x squared minus 9 right away, or do I have to factor that further? 3 and negative 3. So I know that my zeros here will be plus or minus 3, and my other zero here was 2. What synthetic division allows you to do is it allows you to factor quickly if you already know one of your zeros. Synthetic division is really nice. We use synthetic division for 6-5, 6-6, 6-7, and 6-8. It's all the same stuff. Given a zero, find a zero, synthetically divide, find other zeros. There are many different things that we're going to be able to do using this process of synthetic division. Okay? Let's do this one. I don't know. Over time, even a monkey at a typewriter will type out the Magna Carta. So if I have f of x is x cubed minus 8x squared plus 4x plus 48, and I'm going to be given that one of the zeros of the function is 4, my term is x minus 4. So I know at the very end I will have a term of x minus 4. If my 0 is 4, what goes out on the outside of the synthetic division sign? 4. Inside are just all of my coefficients again. 1, negative 8, 4, and 48. Again, I don't have to worry about any placeholders. Everything works out nice and clean. What do you do first? Bring down the 1. 4 times 1, negative 8 and 4. 4 and negative 4. 16. 8 and 0. So your new trinomial what times what's negative 12? Add together to get negative 4.
Negative 6 and 2.
Good. Negative 6 and 2. And the zeros of the function are
6 and negative
6, negative 2, and 4. Synthetic division breaks something down
You
real
ever
fast.
visited Mr. Murphy?
Always. Okay? Want to do one more?
Yeah.
You guys see that one okay? 2x cubed minus 14x minus 56x minus 40, and the 0 is 10. I'll put it on a separate sheet.
Oh, no.
So, if 10 is a 0, what's the term? X minus 10. So I know that that'll have an x minus 10 at the end.
It was already
Well, you guys do this one. I'll write it down in here in a second. I'm assuming you guys are all about here, right? What's your first rule of factoring? What's the GCF? 2x squared, 6x, and a 4? Take the 2 out of there, guys. Don't make your life any more difficult than it needs to be. I haven't. What times what's 2 you add together? You get 3.
2 and 1. 2 and 1.
Hence your life is difficult. And last but not least, your zeros are. When you take out that 2, does it make any difference to anything? No, it doesn't. Because it's just a constant. If it was 2x, we'd have issues. But since it's just a 2, it's all it is.
So what would you do with this
This would have been different. You won't have that issue. Remember, if it was a 2x, if you had 2x out here, then you had more junk in here, you'd have 2x equal to 0, something here, instead of all of them equal to 0. Okay. But you're probably not going to have that scenario when you're dealing with the synthetic. Hopefully. If you do, you might have done something wrong. Do these, please.
Oh, you should give us a break someday. Some nights down the road.
You should just think about it.
Just pleasantly surprise us and just say
Just
no.
say, guys,
Oh, man. That's funny. Hey, you know what? You don't have to do this. I just would recommend that you do this.